Welcome to Lecture Online. Now let's find the max or min using the partial derivatives. What we have here is we have a semi-sphere. Notice the equation describes the sphere, z squared plus y squared plus x squared equals 1, but we only take the values for z greater than 0 or equal to 0. If we now make the z a function of x and y, we can write z equals the square root of 1 minus x squared minus y squared. To find the maximum point on that particular graph, what we can do is take the partial derivative with respect to z, or I should say the partial derivative with respect to x, and then the partial derivative with respect to y. So let's do that. So the partial derivative of z with respect to x is equal to, this is to the 1/2 power, so we write 1/2 times the contents, 1 minus x squared minus y squared, to the minus 1/2 power times the derivative, what's inside, but again it's the partial derivative with respect to x, so 1 and y are constants, so what we have here is a minus 2x. This can then be written as 1/2 times a minus 2 is 1. That would be a minus x divided by the square root of 1 minus x squared minus y squared. Again, now we take the partial derivative of z with respect to y. The partial of z with respect to y is equal to, again like before, 1/2 times 1 minus x squared minus y squared to the minus 1/2 power times the derivative, what's inside. Again, it's a partial derivative with respect to y. That means these are constants, and we get minus 2y, which can be written as minus y divided by the square root of 1 minus x squared minus y squared. Which means this here tells you the change of the function with respect to x, keeping y constant, and this represents a change in the function with respect to y, keeping x constant. So maybe what we can write here is, in this case, y is constant, and in this case we can say that x is constant. Now to find the max or min, just like before, with regular derivatives, we're simply going to set the derivative equal to 0 and solve for the variable. So we're going to set, first of all, we're going to set the partial of z with respect to x equal to 0, and we're going to set it equal to minus x divided by the square root of 1 minus x squared minus y squared. That means if this is equal to 0, by necessity, x must equal 0, which means we find a maximum or minimum at x is equal to 0. Now we can set the partial of z with respect to y equal to 0, and when we do that, we can set it equal to this, which is equal to minus y divided by the square root of 1 minus x squared minus y squared. Again, if this is equal to 0, if a fraction is equal to 0, the numerator must equal 0, which means that y equals 0. That means that at x equals 0, y equals 0, we get a, and I'll go ahead and put it like this, we get a max or min. Of course, since we know what the equation looks like, we already know that that's going to be maximum value. Now, what we could do is we could determine what the slope is going to be like at values slightly off from x equals 0. For example, when I plug in x equals 0.1, what do we get? When I plug in x equals negative 0.1, what do we get? So what I'm going to do here is I'm going to find the slope at either side of x equals 0, again keeping y constant. So I'm going to go take this equation right here, take the slope, and find the partial of z with respect to x when x is equal to 0.1. If we do that, what do we get? Well, we plug in a 0.1 there, so this is equal to a negative 0.1 divided by the square root of 1 minus, that would be 0.1 squared minus 0, because I'm not going to change. What I'm going to do is I'm going to let y equal be a constant. I'm going to set y equal to 0. Notice that the denominator here is positive, the numerator is negative, which means I get a negative value. That means the slope is negative. When we go back to the drawing here, you can see that when x is equal to 0.1, which is on this side of the plane of the yz plane, we can see there that the slope is negative, and that makes sense because the curve is going down in that way. So we have a negative slope. Now if I plug in x equal negative 0.1, the partial of z with respect to x, where x is equal to a negative 0.1. This is equal to a negative times a negative, or a positive 0.1 divided by the square root of 1 minus 0.1 squared minus 0. I know that this was a negative, but oh, that was a negative. I'm sorry. I'll put the negative over here. That's a negative, but since the squared becomes a positive, and so this will give us a positive value, and that's of course against the slope, which means if I pick a point just to the back side of the YZ plane, I have a positive slope. I have a negative slope here, which indicates positive slope on one side, negative slope on the other side. That means I have a maximum point there. So this is one way to figure out that I was dealing with a maximum point. We can do the exact same, keeping x constant and finding some values for y, but that would look exactly the same, so we don't need to repeat it twice. So this is a good example of how to use partial derivatives to find the maximum or the minimum value of a function. Again, solving for one of the variables in terms of the others. Z now becomes a function of x and y. We take the partial derivative, set it equal to 0, and find the maximum point that way. That's how it's done.